Hello, my name is Stefan Abgarian, and for my TA teaching demonstration, I want to show how to convert hexadecimal representations into binary representations. So first, let's consider the hexadecimal 0x5DC7. So, first thing to note is that the 0x is just used to denote that this is a hexadecimal, so the real thing we're paying attention to is this 5DC7. Now, to convert these individual numbers into hexadecimal, we need to into binary. We first need to understand how binary works. So, binary, to put it simply, is how to represent these normal numbers, like 5, we'll get to D and C, and 7 as combinations of base 2 numbers. So, to show this, 2 to the 0, 2 to the 1, 2 to the 2, and 2 to the 3. These are 1, 2, 4, and 8. And we're basically looking for how do we represent these numbers up here. So like 7 has a combination of these numbers down here. So let me show you an example. So we have 7 here. Can 8 be subtracted from 7? No. So we put an 8 here. We put a 0 here. Can 4 be subtracted from 7? Yes. So we put a 1 here. Can 2 be subtracted from 3, which is what's left over here? Yes. So we can put a 1 here as well. And can 1 be subtracted from 1? Yes, of course. So we have the binary representation of 7 is 0, 1, 1, 1. So let's write that over here. Now, for D and C, this is where things get a little interesting. So to represent numbers above 9, hexadecimal uses letters. So A is used to represent 10, B is used to represent 11, C is used to represent 12, D is used to represent 13, E is used to represent 14, and F is used to represent 15. Now, we're trying to convert C, so how do we write 12 as binary? So, same method as before. Can 8 be subtracted from 12? Yes. That gives us 4. So, we can put a 1 here. Can 4 be subtracted from 4? Yes. That leaves us with 0. And since 2 or 1 can't be subtracted from 0, we can just write 0, 0 here. So, binary representation of 12 is 1, 1, 0, 0. So let's write that here. Now, next what we need to do is convert D into binary. So, as we can see with the chart on the left, D is just 13. So, can 8 be subtracted from 13? Yes. Can 4 be subtracted from 5? Also yes. Can 2 be subtracted from 1? No. So we put a 0 here. And 1 can be subtracted from 1, so we put a 1 here. So the binary representation of D is 1, 1, 0, 1. Now, finally, we need to convert 5 to binary. And compared to D and C, this should be relatively straightforward and simple. So, 5. Can 8 be subtracted from 5? No. So we put a 0 here. Can 4 be subtracted from 5? Yes. So we put a 1 here. 2 can't be subtracted from 1, so we put a 0 here. And 1 can be subtracted from 1, so we put a 1 here. So we have 0, 1, 0, 1. So write that over here, and boom. This whole thing over here is the binary representation of 5DC7. Congratulations.